In this example, we're going to look at simplifying a rational expression that's complex. The first thing I want to do is I'm going to separate this into two parts. I'm going to look at just the numerator, and then I'm going to look just at the denominator. We're going to simplify those as much as we can, then we're going to work on the complex part of it. In the numerator, what I need to do is I need to add these two rational expressions together, and I'm going to do that by getting a common denominator. The common denominator for this is going to be the product of all unique factors. The product of all unique factors, meaning my unique factors of x plus 5, and I have a unique factor of x plus 2. So this is my common denominator. Now multiply each fraction by, I like to say, what's missing from that common denominator. For instance, look at this denominator. If you compare it to my LCD, what's missing? The x plus 2. So we're going to take and multiply the top and the bottom by that x plus 2. Do the same process with the second fraction. If you compare that denominator with my LCD, what's missing? X plus 5. So multiply the top and bottom by x plus 5. This is getting that common denominator. Now let's see what I have whenever I do that. In my denominator, I have that common denominator. And in my numerator, I have x times x plus 2 plus, my plus sign right there, 3 times x plus 5. Okay, we're going to work piece by piece. We're finished for the moment with the numerator. We're going to continue working on simplifying that, but let's look at the denominator. Well, let's do that same process with the denominator. The LCD is going to be, again, the product of the unique factors, x plus 2, x plus 5. What's missing from this denominator is the x plus 5. So multiply the top and the bottom by what's missing. What's missing from that second fraction? X plus 2. So take and multiply top and bottom by x plus 2. Now let's see what we have. In our denominator, we have that common denominator. And in the numerator, we have 2 times x plus 5 minus x times x plus 2. We're going to take this and we're going to look at on a clean sheet of paper how we can simplify this further. Okay, so in the numerators of each, we can simplify these. We're going to simplify by distributing the x and the 3, as well as the 2 and the negative x. We get x squared plus 2x plus 3x plus 15 2x plus 10 minus x squared minus 2x. Okay, now to save time and space, we're going to do two steps in one. And that is simply, we're going to go ahead and combine our like terms here, combine what we can here. Notice that the 2x and the negative 2x will cancel out, leaving me with 10 minus x squared. We're going to do that step, and then we're also going to do the complex. Now this big bar here, what does that double as? That's not just a fraction bar, that's also a division sign. So when we're dividing, remember that phrase keep, change, or it's a phrase you can use, keep, change, flip. So let's look at keep the first fraction the same, or the top fraction. My top fraction is x squared plus 5x, combining those like terms, plus 15, all over x plus 5, x plus 2. We're going to change from division to multiplication. And this works with all dividing by fractions. And then we're going to flip that second fraction. So now this is going to be in the numerator. And my denominator is going to be 10 minus x squared. Now we're going to cross simplify. What do these diagonals have in common? The only thing that we can simplify are those diagonals right there. Cross off what they have in common. And now once we cross off what they have in common, we can just multiply straight across. So, since I have just one here and one there, we're left with this in the numerator and this in the denominator. This is as simple as it gets.